Alright folks, we're going to go over the first worksheet here. It covers a lot of stuff. It covers bonding review, it covers ion charges and simple ionic compounds. What you need to do is decide what of this you need to look at and kind of fast forward to the areas that you need, because again this is a long one, so just figure out what you need and go from there. Okay? First thing you have to do is you have to be able to identify your stair-step line, and from that you need to know that over here on the left are the metals and over here on the right are the non-metals. And you also have to know that hydrogen belongs over with the nonmetals. Okay, hydrogen is not a metal. Hydrogen is a gas. Okay, so long as you know that, that'll help you when you are trying to identify compounds. Okay, so when we look at a compound, for example, this first thing is silver, and the second thing is oxygen. So we know that silver is a metal. So again, you need to pause the video if you don't have your periodic table out, because you're going to need your periodic table as we go through this. So silver is a metal, and oxygen is a non-metal. So your first one is clearly going to be ionic, because you have. Alright, what I'm going to do to avoid writing a bunch of stuff, I'm just going to identify these with an I, because it's ionic. Alright. Oxygen is bonding with itself. Oxygen is a non-metal, so that means it's going to be covalent. Because remember, an ionic bond, let's just do this for a second. Ionic is a metal to a non-metal, and a metallic bond is a metal to a metal, or just one metal itself. And covalent is a non-metal bonding to a non-metal. So that's kind of your guide to doing this. Right. Let's look at NH3. This happens to be ammonia. Nitrogen's a non-metal, hydrogen's a non-metal, so that's covalent. Ag is just silver, so that's going to be metallic. And iron is just silver, so that should be metallic. And sodium chloride, sodium is a metal and chlorine's a non-metal, so that should be ionic. And then this complicated thing here, well, look at the thing right here. That's a metal, and clearly this stuff over here is a non-metal, so this thing is going to be ionic as well. And if you look up W, if you find it on your periodic table, W is tungsten. And so that's a metal. Tungsten is a metal, and carbon and oxygen are non-metals, so that thing is ionic. And then this one is something that you would say is going to be covalent. And I'll tell you, this is a trick question because you don't know about the NH4 thing yet. That's a polyatomic ion. We're going to talk about that in a later podcast. This happens to be ionic. Now, if you put covalent, that's okay, but this is going to be ionic, and you'll find out why later. Okay. You need to, again, be able to take out your periodic table, and you need to identify charges. So if you haven't done that, pause the video and write down the charges for each of the columns that you know, and then come back and I'll do it. Okay, your first column, those are your alkali metals, it's +1, and your alkaline earth metals are +2, and we ignore everything in the middle. So we ignore your D block, and we ignore your F block all the way down at the bottom. Boron is +3, carbon's plus or minus 4, nitrogen group is -3, the oxygen group is -2, the halogens are -1, and the noble gases do not bond with anything. You need to make sure that you write that on top of your periodic table before you go any further. Alright, so we have to state the number of electrons either lost or gained in forming each ion. So let's look at bromine, and it says bromine over here is a -1. Alright, so what's happening to bromine? Well, bromine's over here at the right on the periodic table. It's a halogen. And as a result, it is going to gain 1 electron to move over to krypton. So it gains 1 electron. How about sodium? Sodium has a +1 charge. So if it has a +1 charge, that means it is going to lose 1 electron. This gained 1. So just to kind of give you a sense of that, it's losing 1 electron. So again, if it's sodium, it's over here on the left-hand side of the periodic table. It has 11 electrons and 11 protons, and it wants to be like a noble gas. So its closest noble gas is neon, so it's going to lose an electron. All right, I'm not going to bounce back and forth anymore, but I just wanted you to see that. Okay, arsenic. Arsenic takes on a 3- charge. So since arsenic takes on a 3- charge, that means it has to gain 3 electrons. If it has more of a negative charge, it's gaining electrons, and the 3 tells you it's gaining 3. And if it has a positive charge, that means it's losing, and it tells you it's losing 2. And copper is going to lose 1 because it has more protons than it has electrons, so it's lost an electron. Remember, you can never, ever, ever mess with protons. You may only mess with electrons. Alright, so identify the number and kinds of atoms present in a molecule of each compound. Now we're going back to stuff that you would have had in 8th grade science, and frankly probably before that, but let's just look at this really quickly just to make sure that you're familiar with it. We have carbon, and we have 6 of them. That's what the 6 means. And here we have hydrogen, and we have 8 of them. And oxygen, we have 6 of them. Alright, so I'm not going to write those out. I'm just going to go through them. You should be able to do this pretty quickly. Right? Carbon has 5, hydrogen has 8, oxygen has 4, and then this is really strange. It's sodium's out there, but sodium has 1. Right? And another common compound is table sugar, and you're very familiar with this one. It has 12 carbons and 22 hydrogens and 11 oxygens. And ammonium nitrate, which is fertilizer, notice you have 1 nitrogen there, and you've got another one over here. So we really have 2 nitrogens, and we have 4 hydrogens and 3 oxygens. Those are easy, but the 2 nitrogens are separate. And there's a reason for that. We'll get into that later when we're naming ionic compounds. Alright, so again, we identified our charges as +1, +2, +3, plus or minus 4, -3, -2, -1, 0. That should be across the periodic table. And now what you do is we want you to write the symbol for each ion. So be sure to include the charge. So you'll notice the first one is an oxide ion. Oxide, when it ends in IDE, that tells you it's on the periodic table, and it tells you it's an anion. It's on the right. It's a nonmetal. So that's actually oxygen. So that's oxygen. And what kind of charge does it take on? Well, if we had written our charges down, we would have noticed that oxygen is in the -2 column. Plus or minus 4. 4. Thank you. 4. Okay, now over here with our alkali metals, we have +1, +2, and +3 for the boron group. Okay, so let's look at our next one. Our next one is magnesium. Notice that it's magnesium. It's not manganeside. It's magnesium, which tells you that it's on the left-hand side of the periodic table. It is a cation, and magnesium takes on a +2 charge because it's in column 2. So this would be Mg, and it takes on a 2+ charge, and oxygen took on a 2- charge. Nitride, it ends in IDE, so that means it's nitrogen. And if I look at nitrogen, it's in the -3 column. It's over here. So we're going to say nitrogen is a 3- charge. How about aluminum? Well, if we have aluminum, you'll notice it ends in UM. It does not end in IDE. So it is the metal aluminum. And we all know that aluminum is a metal, and we find aluminum, and it's here, and it has a +3 charge. So it's aluminum with a 3+ charge. Sorry. 3+ charge. And how about our last one, which is fluoride? That tells you it's fluorine, and it's going to be on the right-hand side of the periodic table. You should be very familiar with that because it is the most electronegative element on the periodic table. And we look over and we find fluorine, and it's in the -1 group. It is a halogen. So it is going to take a 1 charge. Alright. Criticize this statement. The ionic charge of any metal can be determined from its position, from the position of the element on the periodic table. Well, that's great for column 1, which is +1, and my alkaline earth metals, which are +2, and aluminum, which is +3. But what about all these guys in the middle? Well, we intentionally avoided them. And that's because we don't know what their charges are based upon where they are on the periodic table. So you don't know how to do that yet. So we're going to give you a list of what those are. But for those, you cannot tell based upon its position on the periodic table. You can tell for the alkali metals, the alkaline earth metals, and for aluminum. All right. Now, remember we had mentioned this already, the names with cations and anions. All of your metals, which are over here, they all retain their name. So let's pick something. Let's pick magnesium. It's going to be called magnesium. The things over here on the right-hand side of the periodic table, your nonmetals, these are going to take on something with an IDE at the end. So it would be oxide for oxygen, or nitride for nitrogen, or carbide for carbon, right? Because these are going to end in IDE. So as we're naming these, your cation is going to keep its name, and your anion is going to change to IDE. So as I look at these, let's name them. You should be able to do that easily. Remember, we don't care about the numbers when we're naming. So we look at calcium chloride. And I'm not going to write all these out just because it'll take way too long. So that's calcium chloride. All right. Is there an H in chlorine? I don't know. I don't think so. All right. This is aluminum chloride, barium fluoride, beryllium oxide, sodium sulfide. Let's keep going. Aluminum phosphide, sodium phosphide, cesium sulfide, magnesium phosphide, and cesium fluoride. Now guys, if you need to, you should have your periodic table in front of you when you're doing these. Especially if you're still looking up names. A lot of these names you should have memorized by now. Okay? How about this next one? Pause the video, see if you can do them now that I've started for you. Alright. Aluminum bromide, calcium carbide, potassium oxide, cesium oxide, and strontium iodide. Notice that all of the anions, the right-hand ones, end in IDE. Alright, I'm not going to write down charges again. You know them by now. But now we have to go and do the formulas. So now you're going to have to go back and look at things. And remember, we taught you the crisscross method. So sodium is Na, and chlorine is Cl. And now I say, well, this is +1 and this is -1. So the 1 and the 1 cancel, so sodium chloride is done. How about strontium sulfide? All right, strontium is Sr, and sulfide is sulfur, or S. And strontium has a 2+ charge, and sulfur has a 2- charge. So the two and the 2 cancel each other out, so you're left with strontium sulfide. By the way, guys, I am doing these live. I don't have an answer key, so if I happen to make a mistake, I apologize. Let me know in class. All right. All right. Magnesium fluoride, that's Mg and F. And magnesium has a 2+ charge, and fluorine has a 1- charge. So this is the first time we have to cross them. So we need 1 magnesium, and we're going to need 2 fluorines. So it's going to be MgF2 to make our charges balance. Remember, our compounds must be neutral. All right, rubidium iodide. Well, rubidium is Rb, and iodine is I. Rubidium is an alkali metal. It has a 1+ charge, and iodine has a 1- charge because it's a halogen, so they cancel each other out. How about cesium sulfide? Well, cesium is Cs, sulfide is S, and cesium has a 1+ charge, and sulfur has a 2- charge, so I have to crisscross them, so I need 2 cesiums, so it's going to be Cs2S. Alright, how about radium oxide? Well, radium is Ra, and oxide is O, and oxygen takes on a 2- charge, and radium, you look it up on your periodic table, and it takes a 2+ charge. So the 2 and the 2 cancel, so we just leave it alone. How about barium and phosphide? Well, barium is Ba, and phosphide is P. It's phosphorus. So barium, if I look it up, it is an alkaline earth metal, 2+, and phosphorus, it has a 3-, it's directly below nitrogen. So when I cross them, I have to have 3 bariums, and I have to have 2 phosphoruses. So it's Ba3P2. That one's a little bit more complicated. Got to be careful with that. All right, how about this one? Aluminum bromide. Well, aluminum is Al, and bromine is Br, and aluminum has a 3+ charge, and bromine has a 1- charge. It's a halogen. So that means I need to have 3 of them. So it's going to be AlBr3 because I have to crisscross my numbers, and my 3 comes after bromine. My 1 after aluminum. How about aluminum sulfide? Well, we already know that's a 3+. Sulfur should be a 2-. So we go AlS. And when I cross my numbers, I get 2 aluminums and I get 3 sulfurs. And that will allow my charges to balance, so I have something that will be neutral. How about aluminum and nitride, which is nitrogen? Aluminum has a 3+ charge. Nitrogen has a 3- charge. They cancel each other out. Aln is our final answer. Okay, how about barium and fluorine? Guys, if you've just been watching this and you're trying to learn as you go along, pause the video, see if you can do these without me, and then come back. barium and fluorine. Barium, fluoride. Barium has a 2+ charge, fluorine has a 1- charge, so that is BAF2 because I have to cross my numbers. Lithium and oxygen. Lithium, oxide. Lithium has a 1+ charge, oxygen has a 2- charge. I cross them, so I get Li2O. Sodium and iodine. Sodium is Na, iodine is I. This is a 1- and a 1+. The 1+ and the 1- cancel each other out, so I'm left with NaI. Beryllium. Beryllium and chlorine. Beryllium is a 2+. It's an alkaline earth metal, and chlorine is a halogen. So it is, stop it, so it's a 1-. So I cross them, and I get BeCl2. And strontium nitride. Well, strontium is Sr. Nitride is N. Strontium has a 2+ charge, and nitride has a 3- charge. So when I cross them, I have to have 3 strontiums and 2 nitrides. So it's Sr3N2. All right, folks, that's it. If you have questions, see me in class. Have a great day.